The history of heating effect of electric current starts in the 18th century. It has different milestones that we are going to explore now. The understanding of the heating effect of electric current has roots in the 18th century. Scientists like Benjamin Franklin and Alessandro Volta conducted early experiments with electricity. They observed that when electric current passed through certain materials, such as wires, these materials exhibited signs of heating. In the 19th century, scientists like George Simon Ohm made significant contributions to the understanding of electrical properties. Ohm's work on resistance, published in 1827, laid the foundation for comprehending how materials impaired the flow of electric current. Resistance became a critical factor in understanding the heating effects. James Prescott Joule, a physicist in the mid-19th century, played a crucial role in elucidating the relationship between electric current and heating. In the 1840s, Joule conducted a series of experiments demonstrating that the temperature of a conductor increases when electric current passes through it. He established the principle that the heating effect is directly proportional to the square of the current and the resistance. By the late 19th century, the heating effect of electric current was well understood and quantified. The relationship was encapsulated in the Joule's law, stating that the heat produced is proportional to the square of the current, the resistance, and the time the current flows. This law became the fundamental in the design and understanding of electrical systems. The knowledge of the heating effect of electric current has been instrumented in various applications, from the designing of the heating elements in appliances like toasters and electric stoves to the functioning of the incandescent light bulbs. It's a principle that engineers and scientists leverage to create practical and safe electrical devices. The heating effect of electric current refers to the phenomena where electrical energy is converted into heat when an electric current flows through a conductor. When electrons move through a material that offers resistance, they encounter oppositions to their flow, resulting in the generation of heat. This principle is a fundamental aspect of how electrical devices, from toasters to light bulbs, operate. Imagine an electric current flowing through a wire. As the electrons move, they interact with the atoms in the conductor. These atoms, having a natural resistance to the flow of electrons, cause collisions. These collisions lead to the conversion of electrical energy into thermal energy, manifesting as heat. The amount of heat produced is quantified by the Joule's law. It states that the heat generated is directly proportional to the square of the current passing through the conductor, the resistance of material, and the time the current flows. This relationship allows engineers to design electrical systems with a specific understanding of how much heat will be produced under different conditions. Now let's discuss some of the daily life applications of heating effect of electric current. Electric heaters. Electric heaters commonly found in homes and offices uses the heating effect to generate warmth. The heating element, often made of materials with high electrical resistance like nichrome, heats up when a current flows through it, provides controlled heating in spaces during cold weather. Electric stoves and cooktops utilize the heating effect for cooking. The heating elements under the cookware heat up due to the electric current passing through them, allowing for efficient cooking without the need for an open flame. Toasters. Toasters use the heating effect to brown and crisp bread slices. Bread slices are placed between heating elements, and the electric current passing through them generates heat, toasting the bread. The heating effect of electric current generally sparks multiple questions. Here, we are going to answer 3 of them. First one is, what causes things to heat up when an electric current flows through them? When an electric current passes through a conductor, such as a wire or a heating element, the electrons in the conductor collide with its atoms. These collisions generate heat due to the resistance offered by the materials to the flow of electrons. Second one is, why do some materials heat up more than others with the same electric current? Different materials have varying level of electrical resistance. Materials with higher resistance, like nichrome, used in heating elements, heat up more because they impede the flow of electrons more efficiently, resulting in more collisions and more heat generation. Third one is, how is the heat produced measured? The heat produced is measured in joules. Joule's law states that the heat generated is proportional to the square of the current, the resistance, and the time the current flows. This relationship helps quantify the amount of heat produced under different conditions. In wrapping up our exploration of the heating effect of electric current, we have journeyed from its historical roots to grasping its definition and the laws that govern this transformative phenomena. Answering common questions has illuminated the practical applications of the heating effect in our daily lives. Remember, this is not just about wires warming up, it's about the fundamental interplay of electricity and heat shaping our modern world. Whether you are a curious mind or a student delving into the intricacies of physics, the heating effect is a treatment to the profound impact of electrical current in our everyday existence.